So in this video about electrostatics, we're going to use something called a Vane electroscope. So what it has, it's got a metal disc on top connected to this metal ring here and this metal strip going down the middle. And it also has this kind of free moving metal piece here, which is attached to here via this pin right here. But it allows for it to freely kind of rotate with very little force, so it'll actually cause it to move. So we're gonna see what happens when we play around with moving charges around with our vinyl light strip. So we're gonna charge the vinyl light strip again, okay, just like we did the previous experiment. Again, that gives it a negative charge. It's taking electrons away from the rag itself. Okay, so that rag is giving up electrons due to the friction. And as we bring this close, you can see that we actually caused that strip in the middle, that little part that is the electroscope, to deflect in that direction. Now you notice I'm not touching it right now. So I'm not bringing those charges and touching things, I'm only bringing them close. So it's a pretty simple explanation, similar to they can. We've got electrostatics working here, we've got charge repulsion. So we had this negative charge here in our vinyl light strip. Bring it close to the metal conductor here, the whole setup. And what's going to happen is electrons in this top portion of the dome, in this little kind of level right here, they're going to make their way down and around to the bottom. They're going to try and get away from that negatively charged vinyl light strip. And they're also going to make their way down this vein right here. So this middle vein becomes negatively charged, but because it's connected to this central vein that's moving around, that vein also becomes negatively charged. When that central portion, the part going right down the middle, has a negative charge, and the strip here have a negative charge. That means they're going to repel each other. So basically what we've done is push them away in opposite directions, okay? By deflecting electrons away from this dome into the rest of the electroscope. That leaves the top portion with a positive charge, while the rest of it has a more negative charge. Now this is an acetate strip, see it's clear, and when we apply friction to this one, it's a little trickier because it's a little bit flimsy. It actually donates electrons to the rag, so it ends up with a positive charge. The question becomes, what happens when we place this near? Well, if we actually got a charge, which we didn't. Again, this one's a little bit trickier because it's flimsy, but let's try it out. Again, one more time, we bring this close, and again we see we get a deflection. Now what's going on here? Again, this is positively charged. Protons aren't moving. We are not pushing positive charges away. What we're actually doing is drawing electrons up towards the top. So electrons are now moving from every other portion of this electroscope towards this excess positive charge on top. So we're actually going to build up a negative charge on the surface. That leaves the two middle portions minus some of their electrons. So instead of it being a negative charge deflection in the middle, we're actually end up with a positive charge deflection in the middle. So working along the same principles, but instead this time causing electrons to go up as opposed to being pushed down.